Sea turtles travel across entire oceans every year. They cross thousands of kilometers of open water with no landmarks, no stars, no sound to guide them. Yet somehow, they always return to the exact beach where they were born, their birthplace hidden beneath waves and time. For decades, scientists could not explain how a creature with limited vision and no complex navigation tools could perform a journey so precise it rivals our best technology. Eventually, the answer emerged. Sea turtles can sense something humans cannot see, an invisible force that surrounds the planet, Earth's magnetic field. For millions of years, sea turtles have performed one of the most extraordinary migrations on the planet. They begin life as fragile hatchlings, racing from the sand into the ocean. Then they vanish into the open sea for decades. When they return as adults, they seek the same coastline where they were born. This journey can span 10 to 20,000 kilometers. It must be timed with seasons, currents, predators, and survival itself. Yet these animals never seem lost. Their path is guided by something ancient and precise, something we are only beginning to understand. Early observations puzzled researchers. Turtles maintained accurate routes, even when currents pushed them away, even when storms disrupted the surface, even inside experimental tanks with no light or visual cues. Then a breakthrough occurred. When scientists altered the magnetic field inside these tanks, the turtles instantly changed direction. Their bodies reacted as if the planet itself had shifted beneath them. This was the first clear sign. Sea turtles were navigating by sensing Earth's magnetic field. Earth's magnetic field is a vast structure. It is created by the molten core deep within the planet. Invisible lines curve from pole to pole. The field varies in strength and angle depending on the location. Turtles appear to use this variation as a natural reference system, not with sight, not with sound, but with a biological sense called magnetoreception. Scientists believe turtles use two major mechanisms. The first involves a light-sensitive protein called cryptochrome in the retina. This protein behaves like a quantum compass. It reacts to the angle of magnetic fields. The second mechanism involves tiny particles of magnetite embedded somewhere within the body. These crystals behave like microscopic compass needles. They shift when the field around them changes. Together, these mechanisms let sea turtles detect the planet's magnetic signature with surprising precision. Even more remarkable is a process called magnetic imprinting. When a turtle hatches, it memorizes the magnetic pattern of the beach where it was born. Every coastline has a unique magnetic signature: the inclination of the field, the intensity of the force, the shape of the surrounding geology. This magnetic fingerprint becomes a lifelong address. Decades later, the turtle uses the planet's magnetic map to return to that same beach, often with an error margin of only a few kilometers across entire oceans. Earth's magnetic field is not uniform. Its strength and tilt shift from region to region. This creates a natural coordinate grid. Turtles read two key parameters to determine where they are. The inclination angle tells them latitude. The magnetic intensity offers clues about longitude. By comparing these values to their internal imprint, turtles can adjust their path in real time. They follow an invisible map that humans cannot see. Field experiments reveal the accuracy of this system. Juvenile turtles exposed to artificial magnetic fields behave as if they are located thousands of kilometers away. They instantly attempt to swim in the direction that would lead them back to the real migratory path. In Florida, when Earth's magnetic field drifted naturally over the years, nesting sites also shifted along the coastline. The turtles were responding directly to changes in the planet's magnetic landscape. Their bodies interpret the field constantly, not occasionally. This ability is a survival tool crafted by evolution. It helps turtles avoid dangerous currents, locate feeding zones, and return to safe beaches for nesting. Even small changes in the magnetic field can alter their success. And sea turtles are not alone. Birds, salmon, bees, lobsters, and even dogs show signs of magnetoreception. Earth's magnetic force shapes far more of the animal world than we once believed. Still, many mysteries remain. How does the turtle's brain interpret magnetic information? Is the field perceived as a kind of pressure, a shifting sensation, or perhaps a faint visual pattern created by cryptochrome? No answer fully explains their incredible accuracy. As scientists trace the neural pathways that support magnetoreception, each discovery leads to more questions. The sense appears far more complex than early researchers imagined. In the end, one truth stands out. Sea turtles navigate the world using a force humanity barely notices. They read the invisible architecture of Earth with instinctual precision. While our satellites and instruments attempt to replicate this ability, these ancient animals mastered it long before humans existed, long before navigation became a science, long before we understood that such a sense was even possible. We are only beginning to uncover how sea turtles see Earth as force and follow its magnetic map. And as we learn more about this extraordinary ability, we are reminded of something profound. The natural world holds senses, systems, and knowledge far beyond what we understand today. Perhaps these creatures have always known something about this planet that we are only just beginning to see.